Hi everyone, this is Int3-KC7 Section 1.2 on domain, range, and composition functions. Now, domain and range should be a review for us, but compositions can get a little tricky and confusing. Okay, so let's go over our graphs first, okay, for domain and range. So we've already done quadratic functions. We did it in the beginning of the year throughout first semester, right? A quadratic function is a function that has x squared. And that function looks like a u if I graph it. Now the square root, right, the square root of x is the reverse or the inverse of x squared. Those graphs look like quadratics rotated. Now it's only the top because you cannot have a negative number inside the square root. Okay, it will not exist. It will give you an imaginary number, which we use later on in math. But if you plug this into your calculator, the square root of a negative number, it is going to give you an error message. Okay, so it's basically only half of your quadratic rotated. Now a cubic we've also gone over. Remember, cubic is x to the third. And this looks something like this, right? Like a line that's going both up and down. The cubic root is very similar. It looks like that. It is just, again, rotated. Okay? So we're going to be focusing on graphs that are square root graphs and cubic root graphs. Okay, so let's refresh. Our domain is talking about our x values and where our graph starts and stops on our x-axis. So we're looking at it from left to right. Our range are our y values, and it is where our graph starts and stops on our y-axis, or up and down. Okay, again, this should be a review because we've done domain and range before. It's just going to be written a little differently this time. Okay, so for example, let's find the domain of this graph. So I gave you this graph. Okay, the domain from left to right, it starts here, and it is a closed circle here. So that means that it is a bracket because it is a closed circle, and it starts at 0, 0, and it will go on forever and ever to positive infinity. And similarly, the range, again, it's a closed circle. It is at 2, and it goes to positive infinity forever and ever. And that's it. That is your domain and your range. You do not need to make these harder than they actually are. Now, inverse composition. The inverse composition rule can get a little tricky. Okay, in order for two functions, let's say f of x and g of x, to be inverses of each other, you need to meet two things. You need f of g of x to equal to x when you simplify it, and you need g of f of x to equal to x when you simplify it. If they are equal to x, then they are inverses of each other. If they are not equal to x, then they are not inverses of each other. Okay, now I know this sounds a little complicated, so we're going to go ahead and do some examples. Okay, so I want to figure out if f of x is equal to 5x minus 1 and g of x is equal to x plus 1 over 5 are inverses of each other. Okay, so the first thing I want to do is f of g of x. And what that means is that I am going to look at my function, 5x minus 1, right? 5 times x minus 1. But instead of x, I am going to plug in all of what g of x is equal to. So in here, I have x plus 1 over 5. Now I'm going to simplify wherever I can simplify. So here, with the 5s, I'm multiplying by 5, but then I'm also dividing by 5, so I can really cancel those out. And I'm left with x plus 1 minus the 1 from the original problem. Well, if I simplify this, this will give me 0, so I'm left with x by itself, which is what you want. Okay, now, that doesn't mean that they're inverses of each other, yet I need to prove the other way around, g of f of x now. That also needs to be equal to x in order for this to work. So, let me erase this because now we're going backwards. I am going to rewrite this equation, or of this function, but instead of x, I'm going to put parentheses, plus 1 over 5. And in that parentheses, I'm going to plug in all of f of x, which is 5x minus 1. Okay, now I really don't need parentheses here because I'm not multiplying anything on the outside. So then I can simplify. Negative 1 plus 1 will give me 0. So I'm left with 5x over 5, which will cancel out, and I'm left with x. So yes, these two are inverses of each other. Okay, so I want you to go ahead and pause the video and try example number 2. All right, so again, f of g of x is equal to blank plus 8. And in that blank, in that parentheses, I'm going to plug in x minus 8. Now again, I'm not really multiplying anything here. I don't need the parentheses. And I can just simplify here. This will give me x by itself. Now the other way around. I have some blank minus 8, because it's x minus 8. And in here, I'm going to plug in x plus 8. Again, I don't really need the parentheses here. And I can simplify the positive 8 and the negative to give me 0. And then I have x by itself. So yes, these are inverses of each other. All right, last one. Again, pause the video. Try to do this on your own before I give you guys the answer. So I want to look for f of g of x. So I'm going to write my function 5 times something minus 4. In parentheses, I am going to put in all of g of x, which I get this, x minus 4 over 5. Now a 5 is being multiplied and divided, so they cancel out. I'm left with x minus 4 originally, which gives me x minus 8 when I simplify it. Now this, I cannot simplify anymore, but it does not give me x, which is what I want. So this is a no. Don't even need to show the other part because this already did not give me x. And you're done.